Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Galactic Wonders. Exploring the Magellanic Clouds. The Magellanic Clouds, two irregular dwarf galaxies orbiting the Milky Way, are among the most intriguing and studied celestial objects in the night sky. Known as the Large Magellanic Cloud, LMC, and the Small Magellanic Cloud, SMC, these galaxies are named after the Portuguese explorer Ferdinand Magellan, who documented them during his circumnavigation of the Earth in the early 16th century. The Magellanic Clouds have captivated astronomers for centuries and continue to be a focal point for research into galaxy formation, evolution, and the broader dynamics of our galactic neighborhood. The Large Magellanic Cloud, LMC, is the larger and closer of the two galaxies, situated approximately 163,000 light-years from Earth. It spans about 14,000 light-years in diameter and contains several billion stars. The LMC is characterized by its irregular shape, a result of gravitational interactions with the Milky Way and the SMC. One of the most prominent features of the LMC is the Tarantula Nebula, a massive star-forming region that is the most active starburst region in the local group of galaxies. The Tarantula Nebula hosts numerous young, hot stars and clusters, including the famous R136 cluster, which contains some of the most massive stars known. The Small Magellanic Cloud, SMC, is located about 200,000 light-years away and is smaller than the LMC, with a diameter of around 7,000 light-years. Despite its smaller size, the SMC also plays a significant role in our understanding of galactic processes. Like the LMC, the SMC exhibits an irregular structure, heavily influenced by gravitational interactions with its larger neighbor in the Milky Way. The SMC is rich in gas and dust, which fuels ongoing star formation. One notable feature of the SMC is the wing, an extended region that appears to be a result of tidal forces exerted by the LMC. The Magellanic Clouds are of particular interest to astronomers because they offer a unique laboratory for studying star formation and galaxy interaction. Their proximity to the Milky Way allows for detailed observations that are not possible with more distant galaxies. The interactions between the LMC, SMC, and the Milky Way have led to the formation of structures such as the Magellanic Stream, a trail of gas that stretches across the sky. This stream, which extends over 600,000 light-years, is believed to have been stripped from the Magellanic Clouds by the Milky Way's gravitational pull. One of the key aspects of studying the Magellanic Clouds is understanding their star formation history. Both the LMC and SMC are rich in young, massive stars, making them excellent sites for examining the processes that lead to the birth and evolution of stars. The Tarantula Nebula in the LMC, for instance, provides a glimpse into a vigorous star-forming region where conditions are similar to those in the early universe. By studying the stars and clusters within the Magellanic Clouds, astronomers can gain insights into the initial mass function, stellar evolution, and the role of feedback mechanisms in regulating star formation. In addition to star formation, The Magellanic Clouds offer valuable information about the chemical evolution of galaxies. Spectroscopic studies of stars and gas within the LMC and SMC reveal a range of chemical abundances, reflecting different stages of enrichment by supernovae and other processes. These chemical signatures help trace the history of star formation and the buildup of heavy elements over time. By comparing the chemical compositions of the Magellanic Clouds with those of other galaxies, researchers can better understand the factors that influence chemical evolution on a galactic scale. The interactions between the Magellanic Clouds and the Milky Way also provide important clues about the dynamics of galaxy mergers and tidal interactions. Numerical simulations suggest that the LMC and SMC are on their first infall into the Milky Way's halo, having been gravitationally captured relatively recently in cosmic terms. These interactions are likely responsible for the distorted shapes of the Magellanic Clouds and the creation of tidal features such as the Magellanic Stream. Understanding these interactions helps astronomers build more accurate models of galaxy formation and evolution, particularly in the context of hierarchical structure formation in the universe. The Magellanic Clouds are also significant for the study of variable stars, particularly Cepheid variables and RR Lyrae stars. These pulsating stars serve as crucial distance indicators, allowing astronomers to calibrate the cosmic distance scale. Observations of Cepheids in the LMC, for instance, have played a pivotal role in determining the Hubble constant, which describes the rate of expansion of the universe. The relatively nearby location of the Magellanic Clouds makes them an ideal testing ground for refining these distance measurements and improving our understanding of the scale and structure of the universe. One of the intriguing aspects of the Magellanic Clouds is their potential for hosting globular clusters and dwarf spheroidal galaxies. Globular clusters are dense groups of old stars that provide valuable information about the early history of galaxy formation. The LMC is known to contain several globular clusters, including NGC 1835 and NGC 1841, which are among the oldest objects in the universe. Studying these clusters helps astronomers understand the conditions under which the first stars and galaxies formed. Similarly, the discovery of dwarf spheroidal galaxies associated with the Magellanic Clouds offers insights into the processes of galaxy accretion and tidal disruption. The Magellanic Clouds also play a role in the search for dark matter. The distribution of dark matter within these galaxies and their interactions with the Milky Way's dark matter halo provide constraints on the properties of this elusive substance. Observations of the dynamics of stars and gas in the Magellanic Clouds help researchers infer the presence and distribution of dark matter, contributing to our understanding of the dark matter content of the universe. In addition to their scientific significance, the Magellanic Clouds hold cultural and historical importance for many indigenous peoples of the Southern Hemisphere. For example, the Maori of New Zealand refer to the Magellanic Clouds as Te Aikaroa and incorporate them into their cosmology and navigation traditions. Similarly, the Aboriginal Australians have stories and myths associated with the Magellanic Clouds, highlighting their significance in the cultural heritage of these communities. In conclusion, the Magellanic Clouds are extraordinary celestial objects that continue to captivate astronomers and the public alike. Their unique characteristics, proximity to the Milky Way, and rich history of observations make them invaluable for studying a wide range of astrophysical phenomena. From star formation and chemical evolution to galaxy interactions and dark matter, the Magellanic Clouds provide a wealth of information that enhances our understanding of the universe. As technology and observational capabilities advance, the Magellanic Clouds will undoubtedly remain a focal point for astronomical research, revealing new insights into the workings of our cosmos.